Subatomic particles are the fundamental building blocks of matter and energy that make up our universe. These tiny particles are so small that they cannot be seen with the naked eye, and they exist in a world that is beyond the reach of our everyday experience. The study of subatomic particles, also known as particle physics, is a field of science that seeks to understand the properties and behavior of these particles. It involves the use of powerful machines such as particle accelerators and detectors, as well as sophisticated theoretical models, to explore the nature of the subatomic world. At the heart of particle physics are three types of subatomic particles: protons, neutrons, and electrons. Protons and neutrons are found in the nucleus of an atom, while electrons orbit around the nucleus. These particles are held together by the strong and weak nuclear forces, which are some of the four fundamental forces of nature along with gravity and electromagnetism. However, there are many more subatomic particles beyond these three. For example, there are various types of leptons, such as the electron and the neutrino, which do not interact with the strong nuclear force. There are also various types of hadrons, such as the proton and neutron, which are made up of quarks and interact with the strong nuclear force. Particle physics is an exciting field because it is at the forefront of our understanding of the universe. It has led to discoveries such as the Higgs boson, which gives particles mass, and the detection of neutrino oscillations, which have helped to shed light on the mysterious properties of these particles. Additionally, particle physics has practical applications in fields such as medicine and technology, such as the development of PET scanners and the use of particle beams in cancer treatment. In summary, subatomic particles are the building blocks of matter and energy, and the study of these particles is essential for our understanding of the universe. The field of particle physics has made significant contributions to our knowledge of the subatomic world, and it continues to be a source of exciting discoveries and practical applications. Electrons are subatomic particles that have a negative charge and are found in the outer regions of atoms. They were first discovered in the late 19th century, and their discovery revolutionized our understanding of the nature of matter. The discovery of electrons can be attributed to the work of a number of scientists, including J.J. Thomson, who is often credited with the discovery of the electron. In the late 1800s, Thomson was studying the properties of cathode rays, which are beams of electrons that are produced when a high voltage is applied to a gas inside a vacuum tube. By measuring the deflection of the cathode rays in a magnetic field, Thomson was able to determine the charge-to-mass ratio of the particles in the rays. He found that these particles had a much smaller mass than any known atom, leading him to hypothesize that they were a new type of particle, which he called corpuscles. Thomson's corpuscles were later renamed electrons, and subsequent experiments confirmed their existence and properties. For example, in 1909, Robert Millikan conducted his famous oil drop experiment, which measured the charge of individual electrons. This experiment provided direct evidence for the existence of electrons and allowed for the determination of the charge of the electron. The discovery of electrons had profound implications for our understanding of the nature of matter. Prior to the discovery of electrons, it was thought that atoms were indivisible and that all matter was made up of these indestructible building blocks. The discovery of electrons showed that atoms were in fact divisible, and that they contained smaller subatomic particles. This led to the development of the modern atomic model, which posits that atoms consist of a nucleus made up of protons and neutrons, with electrons orbiting around the nucleus. Today, electrons play a crucial role in many areas of science and technology. They are essential for chemical bonding and the formation of molecules, and their behavior in materials is responsible for many of their physical properties. Additionally, the flow of electrons in electrical circuits is the basis for many technological devices, from computers to smartphones to electric cars. In summary, the discovery of electrons was a groundbreaking moment in the history of science, and it has had far-reaching implications for our understanding of the nature of matter. Today, electrons continue to play a crucial role in many areas of science and technology, and their study remains a subject of intense research and discovery. Electrons are subatomic particles that have several unique characteristics that distinguish them from other particles in the universe. Some of these characteristics include their charge, mass, and behavior. Charge: electrons are negatively charged particles, meaning that they have an electric charge that is opposite in sign to that of protons, which are positively charged particles found in the nucleus of atoms. The negative charge of electrons is essential for the formation of chemical bonds and the behavior of electrons in electric fields. Mass: the mass of an electron is extremely small, approximately 9.11 by 10 carat 31 kilograms, making it one of the lightest particles in the universe. This small mass allows electrons to move quickly and easily through materials, which is important for many technological applications, such as the flow of electricity through wires. Behavior: electrons exhibit wave-particle duality, meaning that they can behave both as particles and as waves. This dual nature is a fundamental aspect of quantum mechanics and is essential for understanding the behavior of electrons in atoms and materials. Additionally, electrons exhibit a phenomenon known as spin, which is a property that is analogous to the rotation of a physical object. Electrons can have two possible spin states, which are referred to as spin up and spin down. This property plays a crucial role in determining the magnetic properties of materials and is essential for the functioning of technologies such as magnetic storage devices. Another important characteristic of electrons is their energy level. In atoms, electrons exist in discrete energy levels, which correspond to different orbits around the nucleus. Electrons can move between these energy levels by absorbing or emitting energy in the form of photons, which is the basis for many technological applications such as lasers. In summary, electrons have several unique characteristics that make them essential for understanding the behavior of matter and the functioning of many technological devices. Their negative charge, small mass, wave-particle duality, spin, and energy levels all play important roles in their behavior and properties, and their study remains a subject of intense research and discovery. Electrons play a crucial role in the structure and behavior of atoms. In particular, electrons are responsible for the chemical properties of elements and the formation of chemical bonds between atoms. The structure of atoms can be thought of as a nucleus, which is composed of protons and neutrons, surrounded by a cloud of electrons. The electrons are arranged in shells, or energy levels, which are characterized by different energy levels and corresponding distances from the nucleus. The arrangement of electrons in an atom is determined by the rules of quantum mechanics and is responsible for the chemical properties of elements. The chemical properties of elements are determined by the number and arrangement of electrons in their outermost energy level, or valence shell. The valence electrons are responsible for the formation of chemical bonds between atoms, which are essential for the formation of molecules and the wide range of chemical compounds found in nature. When two or more atoms come together to form a molecule, their valence electrons interact to form chemical bonds. These bonds can be covalent, in which electrons are shared between atoms, or ionic, in which electrons are transferred from one atom to another. The behavior of these electrons determines the strength and nature of the resulting bond, and plays a crucial role in determining the properties of the resulting molecule. In addition to their role in chemical bonding, Electrons are also responsible for the physical properties of materials. The behavior of electrons in materials is responsible for many of their electrical, magnetic, and optical properties. For example, the flow of electrons through a material is the basis for electrical conductivity, while the alignment of electron spins is responsible for magnetic properties. In summary, electrons play a crucial role in the structure and behavior of atoms. They are responsible for the chemical properties of elements and the formation of chemical bonds between atoms. The behavior of electrons in materials is also responsible for many of their physical properties, making them essential for the functioning of many technological devices.